Hello friends, today we are going to learn about AWS AppSync. So we will see what is AppSync and what is the purpose of AppSync and what are different components of AppSync and how these different components make AWS AppSync work. Okay, so let's start with what is AWS AppSync. So AppSync is basically a serverless solution by AWS to help developers create GraphQL and PubSub APIs. So if you are looking to develop GraphQL based APIs, so you can consider this AppSync by AWS as a very good solution where you can develop your GraphQL APIs. So I'll give a brief overview how AppSync sits between your front-end clients and your backend system. So we can see that here, this is AWS AppSync, which is on AWS. Okay, it is an AWS service, and your front-end clients will be connecting to this AWS AppSync via a GraphQL endpoint. So there will be a GraphQL endpoint which the clients will be using to connect with AppSync, and behind the scene AppSync will be handling all those requests, and it will use different components to complete those requests. Okay, so behind the scene AWS AppSync contains a schema, resolvers, data sources, and a lot of different other components as well. But to start with AppSync, these are the basic three components which you should be aware of. Okay, so let's see them one by one. So first of all, there is GraphQL schema. So if you have worked with GraphQL, you know that GraphQL is based on schema. Okay, GraphQL is a query language for API, and there is a schema associated with GraphQL APIs where we define the queries, mutations, different types, fields, arguments, everything is defined here. So it is kind of a contract between front end and back end, that whatever data which is being passed through the API, that will always be in this particular schema. It will always like adhere to this schema which we have defined here. Okay, so for example, let's suppose that we are building a social media platform and we want the user profile for a particular user. Okay, on our front end system, be it mobile app or desktop app. So we have defined a query named get user. You can name it anything you want: get user profile, get user profile detail, get user data. This is a simple query, and this accepts ID of the user. So in GraphQL, we also define the types of the arguments and types of the fields. So this ID is basically of type ID. We are expecting that the front end will pass us ID of the user, and we will send the user detail as this user type. So we'll also have to define that what this user type will have. So this user type will have name, which will be of string data type, and the age of the user, which will be of integer data type. So when we run this query, the front end runs this query get user and pass the ID. The front end expects that a user object will come, which will have the name and age of that user. Now in AppSync, how do we perform, like how do we make this query happen? How do we get this data for the user? So we have defined our schema. Okay, and now this schema will be attached to some resolver. Okay, so when you define a query or mutation, that query or mutation should be attached to some resolver in AppSync. Okay, so get user will be attached to a resolver, and what that resolver will do, so as the name suggests, the resolver will simply resolve that query or mutation. Okay, it will resolve the data, it will resolve that request, and it will then respond with some response. So resolver is something where we can write our business logic, where we can perform some checks on the inputs. We can pass this data to some other data source, okay, some API endpoint, some backend system, and after performing some logic, we can respond with some response. Okay, now this business logic can be written in VTL. So this is one pain point which I feel, because you have to learn this VTL. VTL is a kind of different language. It's velocity template language. And this is primarily used to write this logic in resolver. Now AWS has started rolling out JavaScript also, but it is on a limited basis. You cannot completely use JavaScript to write these logics. Okay, but now it is being introduced. So hopefully in future it will completely replace this VTL. So you can write your business logic that on when this get user query will be run, what will happen in this resolver. So this resolver then will be attached to some data source. Now this is the real thing in AppSync. You can connect to a whole variety of data sources, or like different data sources in AppSync. So it can be a DynamoDB table. So DynamoDB is kind of a key value based database of AWS. OpenSearch is again a kind of Elasticsearch solution provided by AWS. There is Lambda function where you can write a whole kind of logic, and you can perform a lot of logic there, and you can respond with some data. Then there is a relational database. You can connect to MySQL, database, or any other relational database which is available on AWS. Now, the most fun part is your HTTP endpoint. So you can also connect to any HTTP endpoint. It can be your backend system, your microservices on AWS, or hosted anywhere else, because this can be a public HTTP endpoint. Okay, so you can use a public HTTP endpoint to resolve the data for your queries or mutations. So for example, get user is connected to a resolver. You write some logic there, you connect to a data source. For example, you connect to a relational database, you run a SQL query on relational database for that ID, and you get the user detail. And once the data is resolved, it will again go to resolver. You will get the response from these data sources. You can again transform that response. You can do anything with that response, and then you can send back that response to the front end. So that response will be then checked with this schema. Okay, what user data you're getting, and is that in accordance with that user type defined here? That check will be done. Okay, and once that check is passed, the response will be sent back to the front end. So this is how the whole request response cycle is completed in AppSync. So you can see that your front end is calling AWS AppSync, and behind the scene you have defined your schema, and you can connect with different kind of data sources here. So it's kind of an API hub where you can connect with a lot of different data sources, and you define your single schema here. So a lot of pain with GraphQL development or API development per se is handled by AppSync here, and you just need to focus on your business logic, your API development. Okay, you don't have to care much about other overheads associated with API development. So this is a very good solution while you are developing GraphQL APIs, that too serverless APIs on AWS. Okay, and if you want to learn more about AppSync, then you can check out this official page of AWS, where they have mentioned everything about AWS AppSync. You can check out the resource section, FAQ section, or the development docs, where you can learn how to develop APIs using AppSync. So here, like they have mentioned, what are the different use cases. You can even develop offline APIs using AppSync. There is a solution called Amplify Data Store. You can use this to develop offline applications. You can build real-time applications like chat applications. If you want to develop something like WhatsApp, you can develop that using AppSync without thinking about sockets or other overheads. Okay, you can also manage your IoT data using this AppSync. So it has a lot of use cases, and whole lot of possibilities are there. You can also check out different companies who are utilizing AWS AppSync. So this is a very good solution for developing GraphQL APIs. You can definitely check this out. And in one of the upcoming videos, we can also do a hands-on with AppSync, where we can develop something using AppSync, be it real-time app or some IoT related application. And then we can learn more about AppSync in detail. So hopefully this video was insightful and you liked this video. Thank you very much.